My name is Jacek Matulewski. The software tool I will present, namely the Dynamic Regions Tracker, was co-developed by Leszek Bonikowski and Dawid Gruszczyński, my former graduate students. It's an application that facilitates detecting areas of interests that change their position in time. The areas of interest are the standard tool used for attention analysis in eye tracking research. The software is written in C# for .NET Framework 4.7, available on Windows operating systems. We use OpenCV library with its .NET wrapper called mgucv. Our program can be freely downloaded. Also, the free source code is available through the Git server. This is the outline of my presentation. I will start by justifying the need for such a software tool in the eye tracker community. I will present some common research scenarios in which it turns out to be helpful. Then I will present the tool itself without diving into its code, in which we use the popular OpenCV library to a large extent. Next, the Gaze Data Explorer, which is another software tool, will be shortly presented. It is a software platform that enables the analysis and visualization of the data from the eye tracker experiments. It can use the dynamic regions of interest determined by the tool presented here. Experiments performed with the use of eye trackers are often focused on attention. Thanks to eye trackers, we can determine part of the stimuli the participant was looking at, or when he saw the object for the first time, how long it was observed, or how many times gaze returned to this object. The analysis of such experiments became a serious challenge when the observed elements are moving, or if participant is moving, wearing the so-called head-mounted eye tracker. In both cases, if object move in the stimulus image, or if object move in the image recorded by the head-mounted eye tracker, it is impossible to use the standard static arrays of interest. Unfortunately, usually the position of tracked objects is also not known from the experiment's condition. Therefore, it was often determined manually in keyframes and then interpolated. The advantages of automatic object tracking for locating regions of interest are not used very often due to the need for programming. A typical example of an experiment in which the concept of dynamic areas of interest is useful is studying the visibility of website elements in a situation in which the participant can scroll through the page in a web browser. We also have similar situation when studying interaction with other people, or when the participant's task is to track some objects on the screen. Another example is study of the environment in which the participant is standing still and the environment itself does not change much, but it is possible to turn the head and look around. And finally, the most complex examples in which the user not only looks around but also moves. This is also the case when examining people while driving. Developing the software, we did not create any new algorithm and didn't improve any of them. So what justifies this presentation? There are two reasons. First, as I mentioned, there is no link between communities of computer vision and eye tracking. Therefore, in practice, eye tracker users do not use existing achievements of computer vision. Secondly, we treat this work not only as a presentation of a new tool, but also as an invitation to further joint development. On the next slide, I will provide a link to Git server, allowing one to download the complete source code, propose the changes, and contribute to the projects. It's very welcome. We've tried to design the graphical user interface as clearly as possible. After all, our idea was to lower the entry threshold for researchers who wish to use methods of tracking objects. The video preview panel occupies the main part of the window with detected areas of interest marked on it. Below is a control panel that allows one to add areas, among other things. We do this by pointing a fragment of the image at the first or subsequent frame of a movie clip. The rest of the buttons allow one to load the file, start the tracking process, and terminate it. The right part of the window is occupied by Settings panel. This is where the easy-to-use approach ends. Unfortunately, one needs to know the details of the algorithm in order to control these settings fully. However, the default values of the parameters are selected so that in most cases it is not necessary to change them. It is worth mentioning two common problems of object tracking that are addressed by implemented object tracking algorithms: the disappearance of the object from the camera field of view and the rotation of the object in relation to the camera, the last due to the movement of the object itself or the movement of the camera associated with the participant of the study. In the first case, that is object disappearance, one needs to turn on the object detection algorithm or select the TLD algorithm, which stands for tracking, learning, and detection, that we have included, although it is not available in OpenCV. In this algorithm, the process of long-term tracking of an object is split into three intervening parts: tracking, learning, and detection. During the frame-by-frame analysis, the tracker follows the object using the median flow algorithm, modified to report moments when the object is no longer visible. Meanwhile, the detector, which is the cascade classifier, looks for instances of objects and corrects the tracker coordinates if necessary. To constantly enhance the detector performance, the learning component, based on the PN learning scheme, estimates its error and updates its data to prevent future mistakes by improving the classification. In order to engage this algorithm, originally implemented in C++, we wrote its wrapper in C#. The output of the program is a comma-separated values file, which in each line contains the location and size of one tracked area with its name, location, and the time at which this position is proper. The Dynamic Regions Tracker is a standalone computer program, but it can also be used as an extension plugin for the Gaze Data Explorer, another software tool. It is an extensible platform for the analysis and visualization of gaze data from eye tracking experiments. It allows editing data also by applying the matrix operation on gaze positions, defining the areas of interest, and visualization gaze data. One can plot the gaze position from any record, or plot gaze paths with fixations and saccades marked. Of course, it is also possible to prepare heat maps, attention maps, and other types of visualization as well. An important feature of this program is its extensibility. It is possible to prepare your own plugins that has access to the data and can modify it. This program will be also released soon. The Dynamic Regions Tracker can be downloaded from our website. The link is visible on the screen. The complete source code can also be downloaded from the Bitbucket server, enabling checking the program and its further joint development. If you have any question, of course, feel free to contact me. In addition, I would like to list other gaze-controlled software projects that I am developing together with students in our lab. Gaze interaction is my main activity. The Gaze text entry library with dozens or so gaze keyboards, starting from the classical one that is with dwell-time buttons arranged as in QWERTY layout, through the dynamic keyboards with moving elements, all the way to keyboards based on the gaze gestures, is the first project. Using these gaze keyboards, we prepared an instant messenger that allows one to send SMSs and emails. It is convenient because it does not require any specialized software from the messages receiver. The gaze-controlled client for YouTube service. The photo browser with the possibility of sharing photos with one's partner, her or his family and friends. The gaze board games, for example checkers and tic-tac-toe. And finally, we've prepared the gaze-controlled TV remote control with a dwell-time based gaze interaction interface, as well as with the one based on gaze gestures. The TV is operated from a laptop that has a simple device connected via USB that emits infrared signals to TV set. The whole set of software creates a kind of entertainment center designed for a person communicating with the environment only through his eyes. These are students involved in the projects who were preparing their diploma thesis on gaze interaction under my supervision. And again, I encourage you to contact me, and thank you very much for listening.